Now that we know the empirical rule of a normal distribution, let us try to apply it in this given problem. The problem says that a survey of 1,000 US gas stations found that the price charges for a gallon of regular gas could be closely approximated by a normal distribution with a mean of $3.10 and a standard deviation of $0.18. How many stations charge between $2.74 and $3.46 for a gallon of regular gas? Now again, the parameters that we need in a normal distribution is the mean and standard deviation, but here we are just given the mean, which is 3.10 US dollars. And let us write that down so that we are guided. We have mean that is equal to 3.10 US dollars, and right, the standard deviation is also given at 0.18 US dollars. Now, through the empirical rule, we don't really need to solve for the z-score anymore, but just through the empirical rule, we could already find out the answer to this problem. How many stations charge between 2.74 and 3.46 US dollars? Now, what I essentially do when solving these kinds of problems, especially for normal distribution, is I also try to draw the curve, right? Because it's a normal distribution, so you could always represent your data using the bell-shaped curve. So let me just draw a bell-shaped curve here. Okay, pardon my drawing. And we know that the mean is at the middle, right? It's also the mean. It's also the mode. It's also the median. So the mean is 3.10. Okay. I want to find out how many stations charge between 2.74 and 3.46. Now we know that 2.74 is less than, right? It's less than the 3.10. So I could assume, assuming that this is it's a perfect bell-shaped curve, 2.74 is around somewhere here, and 3.46 is greater than 3.10, so that's approximately around here, 3.46. Now, if I draw a vertical line here and here, what I need to find out is how many percentage, right? This is the area that I want to find out. How many percentage of gas stations in the United States charge between these prices here? Okay, I need to find out the percentage. But how do I do that using the empirical rule? Well, the empirical rule tells us that if you know how many standard deviation your x is away from the mean, then you could have a general idea of the distribution or the percentage of the distribution that lies within that, right? So what I want to find out given 2.74 and 3.46 is how many standard deviations are they away from the mean. So let us solve first 3.46. How many standard deviations is 3.46 away from the mean? Now, to find that out, I first have to find out the difference between 3.46 and 3.10. So that would be 3.46 minus 3.10, which is the mean. This would give me a value of 0.36. Okay, 0.36. So that's the difference between your mean and that x value of 3.46. Now, how many standard deviation is in this value of 0.36? To find that out, I just have to divide this by 0.18, and that would give me 2. So there are 2 standard deviations between the mean and 3.46. Okay, between 3.10 and 3.46. Now, let's look at 2.74. 2.74. Again, we need to find out the difference between the mean and 2.74. So that's 3.10 minus 2.74. And that would give us a value of also 0.36. So dividing 0.36 with 0.18 would also give us 2 standard deviations. So we know that between 2.74 and 3.46, that is essentially 2 standard deviations of the mean. Okay, so that's 2 standard deviations of the mean. Now, what does the empirical rule tell us? If your data is lies, if your data lie between 2 standard deviations above and below the mean, then that's 95% of our distribution. Okay? Here, it's 95% of our distribution. So the answer for this question is, how many stations charge between 2.74 and 3.46 US dollars? Then that's 95% of the total number of gas stations, right? So let me just make a few space here. Okay, so 95% of 1,000 US gas stations charge between 2.74 US dollars and 3.46 US dollars. So this is also considered as our final answer, but if you want to be specific, right? If you want to be specific, what is 95% of 1,000? Then that's 950 US gas stations charged between those amounts. And that's how you apply empirical rule of a normal distribution in a given problem.